Hello guys, welcome back to my channel. In this video, I'll give an intuitive introduction to what a topological space is. So let's start with the motivation. Geometry usually begins with measuring things. For example, the distance between 2 points, the length of a curve, and the angle between lines, the area and volume. But what if we don't care about measurements? Instead, suppose we only care about how the points are connected. Suppose we stretch or bend a rubber sheet. We never tear it. We never glue two different points together. What properties remain unchanged? Topology studies exactly these properties. A metric space gives us a distance function d of x, y. Using distance, we can define open balls, convergence, continuity, and neighborhoods. But can we define these ideas without ever mentioning distance? Instead of measuring distance, we simply declare which subsets should be called open sets. Everything else in topology is built from these open sets. In the real line, 0, 1 is open. So is minus 5, 8. Even minus infinity, 4 is open. But the closed interval 0, 1 is not open. Imagine standing inside an open interval. You can always move a little bit left or right without leaving the interval. This idea captures being inside. Notice that no actual distance values matter. Suppose we have a set X. We now choose certain subsets of X. These subsets will be called open. But not every collection works. They must satisfy three important rules. A topology on a set X is a collection T which is a subset of P of X such that 1. The empty set and X are in T. Any union of members of T is again in T. Any finite intersection of members of T is again in T. The pair X, T is called a topological space. Both empty set and X must be open. They represent nothing and everything. Every reasonable notion of openness should include both. Suppose several regions are open. Their union should also be open. Example, the union of 0, 1 and 2, 5 is still open. Finite intersections preserve openness. For example, the intersection of 0, 5 and 2, 7 equal to 2, 5 is still open. Infinite intersections, however, need not remain open. Let X equal the real number set. Take all ordinary open intervals. Their unions produce every usual open set. This is called the standard topology. Let X equal the set A, B, C. Define T equal to the empty set in X. Only two open sets exist. This is called the indiscrete topology. Again, let X equal the set A, B, C. Take T equal to P of X. Every subset is open. This is called the discrete topology. Suppose T is equal to empty set 0, 1 interval and 1, 2 interval. Their union is the set 0, 2, set minus 1, which is not inside the collection. Therefore, T is not a topology. A metric tells us how far. A topology tells us which sets are open. From open sets, we define continuity, convergence, compactness, connectedness. A topological space consists of a set X, a collection of open sets, satisfying three simple axioms. From these three axioms, an enormous part of modern mathematics is built. If you have any questions, comment down below. Thanks for watching. Drop a sub if you liked it. Bye bye.